Welcome to this talk on functional programming in Kotlin. How many of you know Kotlin? Nice. How many of you have never seen it? How many of you have never heard about it? How many of you are in the wrong room? Okay. Who did Kotlin before May 17th, 2017? Right. That was the day that Google announced at I/O about Kotlin. Who heard of it after that announcement and not before? Yeah, quite a few of you. Like, that just confirms that I wasted 6 years of my life just talking about Kotlin. Thank you. Anyway, I could have just waited for them to say something. So I'm going to give you a brief introduction in terms of functional programming with Kotlin, what is there, what there is not, what you can use through third parties, and yeah, just give you enough so that you can maybe look into it a little bit more if you're interested. Like, this isn't a session for you to actually learn something, right? I mean, like, seriously, conference talks aren't about learning, are they? Did I say that? Anyway. So I always like to start with why, right? So I'll start with why over here. Take a look at this code. Don't judge me. It's only demo code, which is like all the code I write. And tell me as soon as you know what it does, raise your hands. And don't shout. Don't like say, oh, I know what it does. I'll tell you. Just raise your hands and tell me you know what it does. And if you were in my workshop yesterday, don't raise your hand, because that would be unfair. Anyone? No? We got 1, 2, 3. Okay, thank you. Put your hands down. Down? Down, good. Take a look at this. Raise your hands when you know what it does. Right. So, yeah. We get the hands raising much quicker. So when people say, why functional programming? Well, because it's hip, right? It's the hipster thing to do nowadays. But also because it's potentially easier for us to understand, right? The idea behind functional programming is to remove certain things and add certain things that make our code a little bit more understandable and comprehensible. So if you look at these two pieces of code, it does something also. It's exactly the same as it does something. Sure, the return type might be different, but the principle of what it does is exactly the same. And if you take a look at this code, what you're looking at is a whole bunch of code where in your head you have to have this entire mental model of what exactly is going on, right? I have to have a little storage area over here of my cache to cache my variables, to figure out what is going on with those variables, increment them as they go along, figure out what the operations are doing, what each operation is doing, whether it's a statement, whether it's an expression, whether it's what it's returning, store that and try and basically become a compiler, right? And become the application to interpret this. Whereas with this one, it's essentially the same thing. The only difference is that I've abstracted some of that functionality into some other thing which is called a function, right? And I've given those functions good names. So everybody kind of understands what the concept of group by means, even if they do not understand the syntax of Kotlin or they do not understand the concept of what the actual function group by is. But they pretty much know what it means, right? And pair, everyone knows what pair does, and everyone knows what, well, you don't maybe not know what map does, but generally, as soon as you understand what these functions do, this becomes much easier to follow. And that is one of the goals of functional programming. I mean, every person has their own goals around functional programming, but the benefits that I found in functional programming are about essentially raising the level of abstraction, making those abstractions essentially functions, and then using that to write more expressive and concise code. And there's an important factor here because concise doesn't always lead to comprehensible. Right? We can have concise code. Take one of those esoteric languages on Wikipedia that starts with a B and finishes with a K, and you know that that is very condensed, but it's not understandable. So this is about still keeping code that is comprehensible, right? And that's where I think what you would call because often people say, like, if I'm doing functional programming, Where do I start? Where do I end? What is the, the ultimate epiphany of functional programming? Where is it? It's just a journey that each time you start to understand more and more, and then when you understand these things more and more, that's where you're comfortable, and that's where you can stay. Okay? So now, in terms of Kotlin, what we're going to do is kind of show some of the functional aspects of Kotlin, because Kotlin, as you know, if you're not familiar with Kotlin, Kotlin is an object-oriented programming language with functional constructs. What does that mean? That means it's also a functional language. What is a functional language? Well, there's many definitions. It depends who you ask. If you ask a Haskell programmer, generally they will say it's only Haskell. If you ask a F# programmer, they'll say it's only F#. Generally, the agreed sentiment is that any language that gives support to functions as first-class citizens can be considered a functional language. So what is first-class citizens? The ability that I can essentially have functions that I can pass around as parameters, which give way to higher-order functions. The ability to maybe have some sort of immutability in terms of state management, etc. Is Kotlin a functional language? By far it is, of course. Otherwise, what am I doing here? Like, what are you doing here, right? I'm not going to give a talk on programming in Kotlin functionally and use something like, I don't know, VB. So it is, by that account, functional, because in Kotlin you have the ability to do certain things, okay? But let's go through the basics in case you're not that familiar with Kotlin over here. So let me create a new file, and not a scratch file. Let's go over here, and we'll do Kotlin file live me. I love naming stuff. Okay, so, and what we're going to see here is essentially some syntax for Kotlin. Now, Kotlin object-oriented, so I have a class customer. There you go. That's a class. You've just declared a class in Kotlin. And I can create a function in Kotlin as well that says do print message. And I'll have a value that I'm passing in, and then I can, do whatever I want with that parameter, okay? So this is the basic of a function. In Kotlin, a function by default returns unit. So if you do not specify unit, it is assumed that it's returning unit. Unit is exactly the same as void, except it's not void. There you go. That's my explanation there. The difference is that unit is actually an object. So if you're not familiar, again, object is, in Kotlin, we can have classes, and you can create instance of classes, and then you can also have objects, which are kind of like JavaScript, okay? And please, every time I say JavaScript, think about the good things of JavaScript. I never make the comparison of JavaScript as in all the hell that JavaScript is, okay? So it's kind of like JavaScript in terms of an object. Now, this actually means that Kotlin returns something. In fact, if I do result print message and pass in some value, and then I do a print line of result, this is going to give me back a value, which is actually unit, right? So you can see that it gives me back unit, okay? Now, in Kotlin, you can actually have a function indicate that a function never returns. And you do that by saying that it returns nothing. And when I say nothing, I literally mean nothing. So you write nothing, and then that function never returns. So you can see that this immediately says that this, well, in that case, that one doesn't work. And here, you can see that this is unreachable code, right? Because by all accounts, now the compiler interprets that that function is never going to return. So you wonder, why would I ever want to do that? Well, for instance, there's one function built into the standard library, which is called to-do, implement this. And if you go to to-do, you can see that it essentially throws a not implemented error exception, and it returns nothing, okay? So if anyone ever asks you, what is the top-level object in Kotlin? It's called any. And they ask you, what's at the very bottom? You say nothing. And you're telling the truth. And if you don't know, you just say nothing anyway as well. And they'll think you're right. Okay, so in Kotlin, we try and be concise. I mean, you can see how concise a class is. So I can also do, for instance, a fun sum. If I write sum x int y int, I don't have to do something like this, return x plus y. I can do it much shorter as a single expression function, and just return the value there. Type inference will now allow me to, the type inference will know the return type based on the parameter types, and I can just express every function essentially as a single expression function. Considering most of us now have 4K monitors, we don't even have the limitation of 80 columns, so you can have really, really, really long single expression functions. Okay? Now, this is great, but one of the things that I said around, by the way, that was a joke about the columns. Okay, it's just, I don't care if you don't laugh at my jokes, but sometimes people are like, did he really say something that stupid? Yes, I did. So in Kotlin, you know, you couldn't consider it a functional language if we didn't have the ability to pass around functions, which essentially leads to higher order functions. So now I have a higher order function in Kotlin. I can write higher order, and then this one is going to take a parameter. So I can say it's going to take a function, and then I pass in the actual signature of the function. So in this case, I'll say that this function is an int, and it takes an int and an int and returns an int, right? So essentially what this is saying is that this one is, what this one is essentially taking a function that takes two parameters of type integer and returns an integer, okay? By the way, you can make this really cool. Instead of writing func, I can actually put a lambda. Watch this. I'll put the, is that cool or what? Huh? Like, if you learn nothing else in this talk, you know how to type lambdas now. I'm not going to tell you how to do it, but you know that it's possible. No, it's just with a live template. Anyway, so this is essentially the lambda, which is passing in a higher order function. This is a higher order function that is taking a parameter, which is another function. So now I can call this higher order, and I can pass in the lambda anything that takes this signature. To begin with, I can pass in an existing function. You reference that in Kotlin by just using : sum. Right? So here I am passing in the function sum because it matches that signature, so I can pass this in. If I want, I can actually pass in a lambda. And there I'm having a lambda that is being passed in, right? And what it's saying to me is this hint is essentially saying that you can do this in a more efficient way or a nicer way or more idiomatic way in Kotlin, which is that if a last parameter to a function is another function, I don't have to enclose it in the brackets. So I can just exclude this from the brackets and put it outside of the brackets, right? And the brackets would go here. Now, given that I don't have any other parameters, I can just drop those brackets as well because they're redundant. Okay, in Kotlin, if you have a single parameter, a lambda, you can also put that on multiple lines. So you can do something like that. And if you have higher order functions which are just with single parameter, so we have a hosp, which just takes a single parameter, what you can do is write hosp, and then instead of doing x is x plus y, you can essentially just write it plus y. Okay? So single parameter lambdas can be used with the it name instead of being explicit. This gives me the, similar if you're familiar with Groovy, it's essentially the same thing, right? So these are how you declare higher order functions and how you can essentially, like, you know, have your own. Now, in the language itself, we don't have any higher order functions as such. We have all of that in the standard library, which is a very small library that is part of the Kotlin that ships as runtime. So, for instance, if I do numbers equals 1 to 100, I have a whole bunch of new functions here, right? So, for instance, filter, that I do filter 5 equals 0, and then on this I map that to 20, and then on this, for instance, I can do a for each, and print line the actual result, okay? And now you get this nice little wonderful pipeline of functions, and you can say, look, I'm doing functional programming, okay? And then in about 10 years, we'll go to this, and it'll be 60 lines, and we'll wonder where we went wrong, and we'll call it enterprise functional code, okay? But don't worry, by that time, something else will come around that we'll be promoting. So we'll always have a job in this life, right? We will always have a job, right? We are part of destroying things that we later come and fix ourselves. Okay, so all of these are part of the standard library, which it's all defined as extension functions. So it's very small and available on a whole bunch of different things. Extension functions, for those that are not familiar, in Kotlin you can have any class, you can have extend any type with new functionality. So if I have a string class that I want to do to camel case, I can write to camel case, and now basically this is implemented. Now what happens is that if I take any string, I have the to camel case function, right? So this is now available to me anywhere where it is defined in the package. So these filters and that you see here, they're all essentially extension functions on iterables, generic iterables, so they're available pretty much to everything, okay? This is kind of nice, and also gives us a whole bunch of functionality inside the standard library around strings and extension functions around all of the strings stuff, so which is pretty decent. Also, one thing that we're going to be using that you'll notice as well in Kotlin, you can actually call functions with infix notation. So if I have an extension function that we can call is the same as, that takes a parameter which is value, that checks whether this equals value, and this is the actual instance, then I can write it like this, you know, me is same as me, and also I can write it in infix notation, okay? I can write it like that. Okay? Ignore the error. So is same as, right? So you add the infix, and then you can write it essentially the same way. So this looks beautiful, right? This is, yeah? No? Okay, never mind. Now, before diving more into the functions, let me just point out a couple of things. First of all, well, anybody know what a lambda is? I just showed one, right? There you go. What's an anonymous function? It's a lambda, right? So if you go to Wikipedia, which is the source of truth, and you say whiskey glass, I love whiskey. And you say, you know, lambda, and you come down. Oh, look, I got it right. Lambda is the no, that's not what I want. Lambda computers and computer science. There you go. Anyway, in Wikipedia, it says that lambda, or otherwise known as anonymous function, is blah blah blah. Now, in all languages, lambdas are the same as anonymous functions, except in Kotlin. In Kotlin, we actually have anonymous functions as well. Okay, so if you want to do anonymous functions, you can actually type something like this over here. So, for instance, if I have my higher order function, right? So instead of passing in a lambda like that, I can pass in a fun x, y, and then inside of that, for example, do return x plus y, okay? And why is that giving me an error? Oh. Int, unit, int. Oh, int. There you go. Okay, so that is different to a lambda in Kotlin. So you have the concept of anonymous functions, and you have the concept of lambdas. And this is important because lambdas have certain behaviors that it's important for you to know. So for instance, if I have a function that is a container, and I don't mean Docker because there's way more containers than Docker nowadays, and if I pass in, for example, a lambda over here that takes, for instance, an int and returns an int, right? And then I'll do something like, you know, numbers, val numbers equals 1 to 100, and then I'll do numbers for each. Then if numbers is divisible by 0, right, I'm going to do a return, okay? So if you take a look at that code, and we don't even need this. So take a look at that code, right? That is a Lambda expression in Kotlin, which I'm passing to for each. For each is a higher order function, and I say to you, return. And then I'm going to write here, for example, print line hello, right? And then let's format this. So I'm going to write print line hello there, okay? Let's get rid of all of this. Now, if I take a look, if I say to you, if I run that code container, what is it going to print on the screen? What would you intuitively say? Well, it's either going to print hello or nothing. Which one is it going to be? Hello. Hello. Hi. It's me. No. So yes, no, it's actually not going to print hello. And you're going to like, why? Like, this is completely counterintuitive, right? I'm in the for each, I'm in a Lambda, I'm going to do a return. Why is it not going to print hello? Well, the reason it's not going to print hello is because in Kotlin, when you return from a Lambda, you do a non-local return. You do not do a local return. So that means that this is going to return outside of the container function. And you're like, wait, why? Why is this? Well, let's take a look at the implementation of for each. If you take a look at the implementation of for each, it is looping over elements. It's just a higher order function. However, it's got this little thing over here called inline, right? Now, inline is a very fancy word for copy-paste. So when you actually invoke this, what's going to happen is that it's going to copy and paste that code into the actual the calling code. So it's not going to have like a call stack calling another function. It's going to copy and paste that code. So there is no outer function. There is just one function, which is container. And when you do a return, it's going to come out of that container, right? What happens if I don't have an inline function? So if I declare my own function over here, or an inline function that doesn't, my for each that doesn't have inline, then you cannot do a local return, a non-local return. If you write return here, it's going to give you an error. Now, if you want to actually do a local return, going back to the anonymous function, instead of passing in a Lambda, you can then pass in an anonymous function, as we saw here. In this case, return will actually perform what's called a local return. So it will return to the container. Another way is, if you don't want to do that, you can use the labels, which is essentially the ability to call return at the Lambda. So if this Lambda is called for each, then if this function is called for each, then this return would be at for each, right? If this function is called Joe, then it would be return at Joe. Okay? So, no. This is going to, the question is if it's going to print hello 4 times? No, it's going to repeat it none. Do I? Oh, there. Oh, never mind. That completely changes everything. Right. Anyway, thank you. Bye. So yes, no, that was meant to be outside of the for each. Okay. Okay, so now we'll stop at functions for a moment. One other thing that we have in Kotlin is the ability to have immutability. The ability to have immutability. I'm just a poet today, aren't I? So if I have a data class, for instance, val customer string and val phone string, this is essentially customer, good customer, there you go. Class. Good customer, this is essentially creating a DTO for me with some toString equals hashcode, etc. in Kotlin, and I've got 2 immutable properties. Val means immutable. That means that I cannot read and write, and then I cannot write to them once I've initialized them, right? So you generally want to stay away from changing state. One of the premises of functional programming is stay away from state. And with data classes, for instance, it's always good to have immutable properties, because one of the things that you will remove by having immutable properties is the concept of a data class not actually being valid, right? So let's say that you have a customer, and that customer has read and write properties. At some point, somebody writes to that customer, updates a property. You have to have some now validation logic inside that customer to validate whether it is still valid or not. If you go by the idea that I cannot create an invalid object, make all of your properties read-only, and you know that once that object is created, it's always valid, and you don't have to worry about that. Okay? Now this read-only is great because I cannot do anything like changes. So if I have n equals 1, I can't do n equals 2. I can't do that anymore because this is saying that it's a val, it's read-only, I can't do any assignment. And we have the same things in classes. So if I do val customer and initialize that value, that property cannot be changed. The problem is that there are situations where it can be. So for instance, here I have an object, and I have a property called value, which is val. This means that it's immutable. This means that there is no way for me to be able to do something like this. It is immutable. Okay? This one is also immutable, except it's not immutable, right? Because this one has a property with a custom getter, which is possible in Kotlin, but what it's doing in this case, it's actually changing over time because it's calling a function that the end result of that function is not a constant expression. So in cases where you want to avoid these scenarios, because like while I can't reassign the value itself is mutable. If you want to be explicit about that, that is where you can use the const in Kotlin and indicate that this essentially has to be a constant expression. So it has to be initialized as a constant in order to be able to remain truly immutable. In terms of inheritance in Kotlin, again, we don't close in, if a property has a reference and that reference is another object that has mutable properties, there is no way actually to guarantee the immutability all the way down, right? But otherwise, in this case, you can do certain things to guarantee properties in terms of them being constants. So let's now start to get into some of these things we can do with these data classes, right? So a lot of times when you write some code, you say, for example, process entry, and you write, I don't know, some data that takes a string, and then you say, if data is not empty, then print line data or data print line data is good, else, and then we do our general error management, right, which is throw exception, and we generally just throw exception, like the top level. It's good enough. It's fine. It's fine. Everything is okay. So now, this is cool, okay? This is really, really cool. But this sucks in what sense? This sucks because if I look at that signature is not guaranteeing, it's lying to me, right? That signature is saying this function returns a unit. It's not true. This function can potentially return something else. It's the same as something like this. If I write divide x int y int, right? X divided by y, that's a lie. They've been lying to us all our lives because that is not true. Because for 0, that is not going to return an integer. Yeah? So this is what's called a partial function, in that it doesn't work for all potential input values, as opposed to a total function, which for all potential values, it will work. So how can I be explicit about this, right? How can I say that, for example, process entry can actually throw an exception? Well, we can use checked exceptions, like in Java. No, I'm joking. Or you can just use Java. No. So generally, some people tend to shy away from using exceptions for error management, and they do something like result, right? So now they'll create a class called result, and then in that result, they might have, for instance, a property which is, value, string, and then they'll have another property which is called error, Boolean, right? Which then they'll say, if the result is okay, then I will return result good and Boolean false, and we can use default parameters here. So default. And otherwise, I will return true, okay? Now, that's nice, isn't it? And generally in JavaScript, error is represented as an E so that you can spend time figuring out if it's event or error. So in this case, I will return a result true. Now, what's wrong with you? Oh, need to return. There you go. Thank you. So, what's wrong with you now? E. There you go. So that works, except the problem here is that if I have 2 parameters, or if I have 3 that need to be returned as a result, now I have to figure out, looking at that, what exactly is in the context of a valid result and what exactly is in the context of an invalid result. Which in this case, we move away from this, and we can say, hey, why don't we do something else? Why don't we just have a base class, which is result, and then I can have a class which is success, that inherits from result, and I have a class which is failure that inherits from result too. And why can't I do this? Because in Kotlin, by default, everything is final. So now I can do return success, and here I can do result failure, right? And then the failure success is going to have a property which is value, for instance, of type string. And failure is going to have a property of type message, for example, saying the actual error message. Okay, so now I even get more information here. So this is message. Okay? So, oh, that's not good. Okay, because you can make this nested class as well, which is even nicer because now I can enclose it into a specific context. Okay? So now I can have my result.success and result.failure, and now it gives me more contextual information exactly about when is it a result, when is it a failure. Now it's nice. The problem is that now comes my friend and goes to a file that is not owned by the standard library and says, oh, data class sometimes that also inherits from result. Right? There you go. And now, if we go back to my thing over here, I have just introduced a new class, which potentially I don't know about, right? And now there's a third case. What I'm generally showing you here is the concept of the algebraic data type, which is essentially a type that can be of one type or another type. Now, in Kotlin, as soon as you declare a class open, anyone can inherit from it. If you want to close that hierarchy, what you can do is call it sealed. Right? So instead of open, you create it as sealed, and what that means is that essentially only classes in this specific file are allowed to inherit from this. So in that sense, you do get some safety in that you will see all of the types. So if we go back to live me, you can see that now this gives me an error saying that you can no longer inherit from sometimes. Okay? Now this is a pattern that is quite good, because I can use this over and over again, right? Instead of, I can try and move away from exceptions and move towards this data classes which allow me to return different results based on success or failure. The problem is that it's a lot of boilerplate code that I constantly have to write over and over again. So how can I try and solve this problem? Well, you can use, for example, one of multiple libraries. One of them is called Arrow. Anyone here heard of Arrow? Right? So Arrow has this concept basically built in. Arrow is a library which is available. It was a merge between two libraries. One of them called Category with a K, another one called Functionality. Yeah, you guessed it, with a K. And they joined efforts and made a single library called Arrow. And they offer, out of the box, certain additional functionality to make some of these things smoother. So one of those things that they provide is the ability to have this kind of like this or that data class. Okay? So in this case, I have an either. The either is a type that's available in Arrow that says either something, so the result of something is either the type on the left or the type on the right. So in this case, I can say that this function returns either a not applicable, which in this case is just a simple object, or a double. Okay? Then when I want to return the result, I do either left and the actual result, either right and the actual result. So this starts to be nice, because now I've just cut down all of that boilerplate code that I wanted to write, and I only specifically return the actual type that I want to provide. Now this starts to provide me with some other things that we'll get into, like, for example, is left. Is left, it not only returns the actual ADT for me, but it also returns additional functionality, which then I can call and pass to other functions and kind of do this pipelining that we saw previously, such as one of them, for instance, is left. Is left tells me if the value returned is left or is it is right. Exists will tell me whether, given a predicate, it exists if the value is left, and then from then on, continue to do other types of executions. So moving away from exceptions, we get this kind of like return types that we can use back, use to define how we want to return values. But there are times, for instance, that I want to actually stick to the concept of exceptions. And there's another type that is part of Arrow as well, which is called try, which allows me to exactly do this, right? So in this case, what try does is it essentially says that this signature, this function, can return either an exception or a string, right? So it's being explicit. It is now moving away from lying to me, right? Because if this was just a string, then I know that this is going to just return a string. But in this case, it's saying, no, this can actually fail. So it's kind of like checked exceptions, except you don't have to mess around with all of those checked exceptions. So in this case, I say return a try, and the try, if it's a valid URL, then return the contents. Otherwise, throw exception. So now if I do get page with throw, and I pass in some value, right, and I run this, this is not going to do anything because it's absolutely fine. It's just return the contents. I mean, if I do a print line here, it would return the value of the contents, but essentially, it's absolutely fine. But again, we go back to this isn't only about introducing a type with nothing else, it's introducing a type with more functionality. One of those things is, for example, get or else, right? So get or else, what this allows me to do is say, okay, get this value, or else, if you cannot get this value, if an exception is thrown, do something with it, right? So I can say print line, and then, error occurred, right? And what is this? This is a lambda. So since it's a lambda, it's taking a parameter. If we look at the parameter of get or else, it's taking a throwable. What is the throwable? It's the exact throwable that we're throwing. Since it's a single parameter, I can refer to it as it. Right? I don't have to be explicit. So if I run this and I pass in an empty string, then that is going to say error occurred, and it's going to tell me the actual exception that has been thrown. But it's not throwing the exception for me. If I want to, I could then throw that exception for whatever reason, but it's allowing me to gracefully manage these situations. Okay? So you can continue to use exceptions, but you can do them in a more, one would say, a more subtle and cleaner way. Okay? So, one other thing that you have in Kotlin, which you're all familiar with, is nulls or not nulls. So if I write a string, and that string is nullable, right? And if I do if s is not null, then print line something. This I can do in shorthand by just doing something like, print line s dot length, for instance. This I can do in shorthand by using the safe operator. So I can do save length, right? This is the same as doing an if. Essentially, it's like, if it's not null, then do this, right? Now, this is built out of the box in Kotlin. It's the safe operator. In many other languages, such as, for example, Java, you have option, right? Where you can basically say, if it's not null, then do something. But that concept of option doesn't have to exist only for the case of null. The concept of option is more broader, that exists for something having a value or not having a value, otherwise also known as a maybe. So for instance, here I have a function that returns an option of string, which essentially means, is the value, is it returning an actual value or is it returning empty? Empty can one day be mapped to null. In the case of safe operator, other times it can just be considered empty. And then I can do things like, well, if the result is defined, there is a value. Again, it gives me not only this concept of the data class, but a whole bunch of new functionality on this data class, right? So now I can say, if the value is defined, do something. But what else can it do? So for instance, here what I have is a function divide that now becomes total. Remember the initial function we had that was partial? Now this becomes total. So in this case, what I'm saying is, divide two numbers, option int, and if it's greater than 0, then return the value. You call that with a just. You say empty just the value. Otherwise, return empty. And then in my when statement, I can say when result is none, print line, this won't work. Otherwise, print line result. And t refers to the actual type, the value that is returning. Okay? So now I have this case where I can change between none and some. But let's still continue on with this, because this kind of pattern starts to become cumbersome, right? Because if I'm starting to work with these option types, and every single time that I have this option type, I have to do, if it is empty, do this. If it is not empty, do that. This starts to become cumbersome. Like here, I'm taking an int. Imagine, for instance, that I wanted to take an option as an input. What would I have to do? I would have to come here and say, if we change this to option of int, now I have to say if x is defined, then do something with the result, otherwise do something else. And when you start to have all of these functions that start to take options and you start to chain these, it becomes quite cumbersome boilerplate code. And of course, this is already solved for you, right? Because in Arrow, again, you have the ability to have this built in, which is essentially a map. A map is a general concept that comes from functional programming, which is called a functor, which essentially knows how to work with a value, apply a function to that value. So what I do here is I have a function that's called squareIt_option that takes an actual option, and I say map that with inside values. So map under the covers now knows that if it's not empty, perform this predicate on that. If it is empty, then don't do anything, right? And again, map gives me back the ability to start to do other types of chaining, right? So here I have map. In this case, I have triple option. So I can pass in triple option empty. So now this is essentially not going to return anything because it's triple option of empty. It returns none, right? If I put in a value here, for instance, triple option of just 3, this, if I got it wrong, right, it should return sum 27, okay? And then I can actually get the actual value from that. And we can continue to build on this and take it further. So for instance, here, we introduce another thing, which is essentially flat map, which is very, again, common in functional programming. And flat map is the idea that now I'm not going to just return the value. I'm going to return an option of that and operate on that, and the end result of that flat map has to be an actual option that is returned. This then allows me to take it to the next level, which is something that you may have heard very common in functional programming, which is called binds, right? And if you've ever heard of the type of the monad type, or the type class monad, a monad has this function called bind, which essentially allows me to do monadic comprehensions, which essentially means take all of these different operations that are returning these types, these monads, all of these options, try either. These are examples of monads, right? So we've just seen monads without saying monad. And combine these in operations. So for instance, here, I can now start to do a sequence of operations that are independent, that do not depend on each other, and then combine these and get results and have all of the error handling done for me behind the scenes in a much nicer way. Okay? So the either option, binding, try, all of these are some of the things that are available in Arrow. If you are interested in it, check out the library and start to play with that. It does give you some nice things out of the box. Now, one thing I want to also touch on briefly before we finish, which is very functional in terms of Kotlin, is some other things that you can do with functions in Kotlin. Okay? So let me start with, you're all familiar with the concept of a DSL, right? Domain-specific language, right? Which the explanation of a domain-specific language is a language that is specific to a certain domain. There you go. So I have, for instance, a class configuration that says, for instance, has a string port, a host string, and let's say it has a port information of type port. And then I'm going to have a class port, which has, for instance, a value, and then is secure, Boolean, right? So these are vars because I want to set them. Now, in Kotlin, there's multiple ways to initialize this, right? What you wouldn't do is you wouldn't do like val configuration. Configuration, let's just set some default parameters here. So we'll do that is that, and port is port, and then here we'll say is false, false, and int equals 0, right? So you could do configuration, and then here do configuration, and then set the val config configuration, and then set host host, and then set some value, etc. Or you could do something like with C, and then inside C, now you get access to host, and then you get access to port. So inside here, you would do with port, and then inside here, you would say, for example, value equals 90, and is secure equals true, and then host I could put, for example, 127.0.0.1, right? Now, this is nice. The problem is that this is kind of like a little bit ugly because I've got this with over here, right? And what I want to do is, like, if this is called config, for instance, what I want to do is, why can't I get rid of this and just do something like that, right? And kind of like create my own configuration DSL, right? Just like JSON. Just like anything else. Like, I've created a configuration for configuring my ports, but imagine that this could be some business logic or whatever, like tax information. I want to be able to have this ability to write this kind of code and have completion and have type checking and all of this for me. Can I do this in Kotlin? Well, actually, we can. So what is this? What is exactly that we're doing here? This is essentially an object, right? Config, in this case, is an object. And what I'm trying to do, if you look at the pattern, I'm putting some lambdas. So what I'm trying to do is invoke that object. Can I do that in Kotlin? You can. I can have a class, for example, Q, right? And then I can come here and create a new class, right? By the way, this is actually true. A friend of mine was doing a live talk one day. There was two of them on stage, and he was saying, one of them is like typing, the other one is doing speaking. He says, hey, he says, like, Richard, create a queue for me. So what does Richard do? He creates a queue called foo queue, right? And the other one is like saying, right, now we've got this foo queue, and he says, Richard, create a second queue for me. And what does he do? He creates a foo queue too. So that's why you should never name your stuff foo. So if I have this foo, I can now invoke it. How can I invoke it? You see, I just hit Alt-Enter. That's how I invoke it. So what is this doing? Let's call this foo. Basically, what I want to do is create an operator in Kotlin, which is called invoke. As soon as I do that, I can now invoke this object. So if I can do it there, let's do it here. Let's create an invoke for configuration. Now, when I invoke, what parameter should I be passing in here? So let's see what I need access to. I need access to host and port. What are host and ports? They're properties of configuration, right? Now, what is a high-order function in Kotlin? It's a lambda, right? That takes a lambda. What is an extension function? It's a function. Can I pass extension functions to higher-order functions in Kotlin? Yes, you can. It's unique to Kotlin. The concept is called lambdas with receivers. So I can pass in a lambda with receiver here, which the type is actually an extension function to configuration, right? So this is an extension function to configuration. Given that it's an extension function to configuration, it means that it has access to the properties of configuration, which means that suddenly this is no longer red. And I'll do the exact same operation here. I don't know why this keeps giving me the same thing. So I'll do function. What do I need access to here? Port, right? So I'll do port, unit, and then come down. Voila, I have my DSL, right? So I've done DSL-driven development. I started out with what I wanted, and I've driven it out using Alt-Enter. Yeah, I don't even need to know Kotlin. But the point is here, of course, I've just done a small DSL which is specific to a configuration setting. Now, you might not go to this extent to do something for configuration, but the idea here is that you can really embrace the ability of using Kotlin's functions and lambdas with receivers and the ability to invoke objects and create DSLs for your specific parts of your application. Because, I mean, if you're doing, for instance, things like domain-driven design, right? One of the key aspects of domain-driven designs is to have a ubiquitous language, which is the same language you use in your code matches that of the business domain. And now you can start to leverage that. You know, creating DSLs isn't only about creating HTML. It's a new version of that, which you don't need to. It's called Markdown, okay? Anyway, that's all the time we have for now. I don't know if we have time for any questions. If not, I'm around a little bit afterwards anyway, so.
One question.
One question.
Anybody? One question. Mic's open for that. So just a short question. With the last part, why isn't that default? Is there some drawbacks of having that functionality?
What part is not default?
Or having a DSL on your object? Why would you have to? Why do you have to implement those methods?
Oh, well, I mean, yes. I mean, first of all, not everyone's going to want to have a DSL on their object, right? And that's a whole lot of added code that is going to have to be generated in some sense. Second of all, that technically would only be possible to do using some kind of like post-processing, like using capped, for instance, that Kotlin has, right? Which you can analyze a code base and based on that generate some DSL. But again, it's like, I don't think it would be something that you want to have every single class have this ability, to be honest with you.
Okay, thanks.
Thank you.